4 human beings lit a fire under a capsule and launched themselves deeper into space than anyone has traveled in more than half a century. Since December 1972, we have confined human spaceflight strictly to low Earth orbit. For 53 years, our deep space exploration has been conducted entirely by robots, probes, and satellites, while humans stayed close to home. Look at this photograph from 1972. A human physically driving a rover across the lunar surface. We had the capability, we proved the engineering worked, and then we stopped. The April 2026 launch of Artemis II ends that pause. Humanity is returning to the physical exploration of the solar system. Look at the machine required to break this stagnation. This is the Space Launch System rocket, captured at the exact moment of liftoff. This chart compares the thrust of the legendary Saturn V on the left with the modern SLS on the right. The SLS generates 8.8 million pounds of thrust, a 17% increase over Apollo, equivalent to firing 160,000 car engines at the same moment. Inside the capsule at the top of that rocket are Commander Reid Wiseman, Jeremy Hansen, Victor Glover, and Christina Koch. Glover and Koch represent a new demographic of explorers, flying as the first Black astronaut and the first woman on a lunar mission. We strapped 4 people into a brand new capsule, placed them on top of a completely untested next-generation rocket, and triggered an explosive launch to hurl them into the void. On day 2 of the flight, the main engine fires for 5 minutes and 49 seconds. This translunar injection burn accelerates the Orion capsule fast enough to physically tear it away from Earth's gravitational pull. During the next 3 days of quiet transit, the crew watches out the porthole as their entire world physically shrinks down to the size of a marble against the blackness of space. This expanding diagram maps the actual distance between Earth and the Moon. Most people picture them close together, but the physical gulf separating them is staggering. By the time they splash down, the crew will clock a total mission mileage of 695,081 miles. You would have to drive around the entire circumference of the Earth 28 times to match that distance. Pushing out to this range creates an absolute point of no return. A standard emergency rescue from low Earth orbit is physically impossible out here. You are completely on your own. To mitigate that isolation, engineers rely on this flight path. This diagram outlines a free return trajectory, a physics-based safety mechanism designed specifically for deep space travel. If Orion's primary propulsion system completely dies out near the Moon, the crew doesn't drift away. Lunar gravity automatically catches the capsule, slingshots it around the far side, and flings it back toward Earth. Physics does the driving. But gravity only guarantees the capsule makes it home. Artemis II is the first live deep space test of Orion's internal systems, with actual humans breathing the air, drinking the water, and relying on the radiation shielding. Orbital mechanics provide a flawless boomerang back to the atmosphere. But if the internal life support fails in the vacuum of space, that free ride home becomes lethal. There is a specific physical boundary standing in the void. In 1970, the crew of Apollo 13 was forced into a wide survival orbit, accidentally setting the absolute human distance record at 248,655 miles. As Orion swings around the far side of the Moon, it approaches that 56-year-old boundary. On April 6th, Orion crosses the line, reaching a new peak distance of 252,760 miles. You could stack 10 Earths between the capsule and the ground. Crossing that specific marker is the physical proof that our modern spaceflight architecture can finally outreach the technological limits set in the 20th century. On day 10, the capsule hits the Pacific Ocean. Both the crew and the hardware survived the extreme 3,000-degree friction of atmospheric re-entry. Notice this actual piece of Orion flight hardware. Validating this specific capsule under live deep space conditions clears the path for the Artemis III mission to place boots directly onto the lunar surface. We are using the Moon as a proving ground. The objective is to establish a permanent lunar base, test our long-term survival tech, and ultimately launch human missions to Mars. Half a century of remaining in low Earth orbit was a necessary period of technological preparation. We are now building the permanent infrastructure to expand human presence outward into the solar system.